So sometimes we think of radioactivity as a bad thing, but actually, these radioactive elements have helped us to discover lots of the answers to lots of scientific questions. One of them is about the age of the Earth. How did we figure out that the Earth was like 4.5 billion years old? Well, the answer is radioactivity. So let's read this article together. How did scientists calculate the age of the Earth? The Earth has high mountains, deep oceans, and sprawling glaciers. But how old is the Earth? Scientists have determined that our planet is about 4.5 billion years old. How did scientists determine that age? They used geology, math, and chemistry. First, they learned about the rocks and elements that make up our planet. Then they used that knowledge to figure out a way to tell the age of the rocks. Scientific method used, but it yielded poor estimate. In the 1800s, scientists tried to determine the age of the Earth. One of them was a famous Irish scientist named Lord Kelvin. He studied physics and math. Lord Kelvin thought that if Earth began as a mass of melted rock, it had to cool. He tried to figure out how long it would have taken to cool. In 1862, he said that the Earth was between 20 million years old and 400 million years old. His estimate was wrong, but the way he tried to solve it was right. He drew conclusions based on what he could see or observe. He also drew conclusions based on what he could figure out using math and on what was known about physics at the time. Although his estimate was wrong, Kelvin used an accurate scientific method. And this is Lord Kelvin. I was thinking about growing my beard like that. What do you guys think? Getting closer using relative dating. Scientists also tried to compare layers of rocks to figure out the age of the Earth. This method is called relative dating. Scientists try to determine how old each layer is by comparing it to another layer. This method can show which layers are older or younger, or which events happened first. Relative dating could not give scientists the exact age of those rock layers. However, it did tell them that the Earth was most likely billions of years old. Scientists turn to radioactive elements. Here we go. Advances in science continued. In the early 1900s, scientists discovered radioactive elements. These elements decay or break down into other elements. Scientists figured out how each element breaks down, what it turns into, and exactly how long that takes to break down. The amount of time it takes for half of the original element to break down is called its half-life. The decay is like a clock, counting down how much time has passed. So remember when we were learning about Marie Curie and we talked about how radioactive elements kind of break down and send off little bits and pieces of their particles? Well, as they do that, they break down, right? They turn into something else. And if we can discover, how long it takes for half of it to break down, that's called the half-life. Here we go. Scientists use a certain process to tell the age of a rock or mineral. First, they measure how much of the original element is left. Then they measure how much of the new element has formed. They use the half-life to tell how much time has passed. This method is called radiometric dating. Studying moon rocks produces breakthrough. One problem with radiometric dating is the rock cycle. During the rock cycle, rocks change forms. Old rocks are destroyed as they slide back into the earth. New rocks form when lava cools and solidifies. The rocks are constantly changing, right? So how can we measure how old a rock is if it's constantly changing? The first rocks that formed on the earth are no longer here. This makes finding an age for the earth difficult. The oldest rocks that have been found are about 3.8 billion years old. However, some tiny minerals have been dated at 4.2 billion years. To get around the difficulty presented by the rock cycle, scientists have looked elsewhere in the solar system for even older rock samples. They have examined rocks from the moon and from meteorites, neither of which have been changed by the rock cycle. Radiometric dating has also been used on these rocks. Scientists have used all this data to estimate the age of Earth at 4.5 billion years. So the moon was once part of the Earth, right? It broke off a long time ago. And because the moon does not have a rock cycle, it doesn't have lava and volcanoes and stuff, those rocks aren't changing. So if we date the rocks on the moon, we can tell how old they are, and that kind of tells us maybe how old the Earth is. But again, remember, it's just an estimate. We don't know exactly. right? We can't tell you it's 4.5 billion years, 7 hours, and 12 seconds old. It's an estimate, all right? But for now, the best that we can do.